G'day, Michael here. This is the part that I'm aiming to print right now. It is one of my ducting knuckles, a bit of a refined design, so there's less catching points for the various materials going through the dust extractor. Now this is kind of the latest version of a part that's got a female end on one end, you can see the relief, and the male part which is designed to clip inside the female. So you'd use them consecutively and I'd get probably, looks like about 15 degrees of turn with each knuckle. So I can stack them together and make basically a pipe, but I can change the angle knuckle by knuckle to get a curve out of it. Alright, so that's the part intended in the design. Here you can see a close-up of the fill vectors of the 3mm in thickness that I intend to use. Well, it's actually in the machine right now running. And there's the support material to hold up where the reliefs are done. Okay, so I'll move across to the printer. Now, here's the new Prusa machine in action. I'm already missing the speed of the Delta, because the XY stage, what we have is the machine here has to accelerate the 2 feeder motors for the hot ends, and they actually weigh quite a bit. I haven't actually weighed them, but you know, a good ½ kilo is what it felt like to me, whereas the Delta is on accelerating a printhead that weighs in the order of about 50 grams plus the hot tip. It's probably more like about 70 grams. Okay, so the advantage of this, of course, is because it has 2 feeders, I can use 2 different materials. Here you can see just 2 different colours temporarily. It's enough for me to learn how to use it. But they're the 2 different colours being fed to it. And the cost of that is that we have, I don't know if it shows up at the shelf, but I've got 2 printheads there. But you can see they're 32mm apart, and so they actually cost a fair bit of width on the table. I still managed to wring trimming bits off and basically hacking the machine. I'm able to get 180mm in width out of this 200mm nominal machine, even though it's missing 32mm because of the 2 heads. Like this. Okay, so you can see the speed that it's printing is a lot quicker than a screw machine would typically do, but it's still a lot slower than the Delta. I'm also using a slightly finer tip. I'm using a 0.3mm tip, which I guess is probably costing me another 30% overhead for speed. I'm not sure that these hot ends can handle the same amount of material going through them either. They should, I would imagine, but yeah, I'm uncertain in any case. I'd need to try the same size tips to really get a feel for it. But the Delta unit certainly copes with a much higher flow of material going through it. But of course the Delta cannot print compressible materials, which this can. You know, there's rubber-like filaments you can use through these extruders, and I aim to have mixed material parts. That's part of the reason I bought this machine. I mean, it's not much of, quality-wise it's not the greatest machine, but it's giving me basically an introduction to using this style of printing, and I'm fairly convinced I don't want a screw-based machine, although having said that I'll probably buy one soon enough. But yeah, that's about the limit of this machine, I think, for speed. You can hear things are rattling and it's about it. But nonetheless it's a lot quicker than screws, but it's certainly a lot slower than the Delta. Alright, so how long is this going to actually take? Change desktops, where are we? Okay, the calculation is for 1,096 minutes. What is that? 96, 60. Okay, so it's looking like it's going to cost me about 18 and a quarter hours. Okay, so that's fairly slow. I think this part on a screw machine to be twice that anyway. On the Delta with the slightly larger tip, I'm getting sort of 5 to 8 hours depending on how dense I make the print. This one will probably be an 8-hour print on the Delta. I haven't actually done this particular part on it. But yeah, so you can see the cost overhead of all extra features on this printer is quite high relative to the Delta. There's not really a cut and dried, clear advantage to any particular machine. Like you can't say this is the best or that's the best. It's all, they have certain attributes, and you take with the rough with the smooth, and these this is a large part and it costs time with an extruder. There's no shortcut. This would actually work with a resin projector arrangement quite well, but I had a comment on one of my other videos about how these are pretty much obsolete machines. Well, they kind of are, and to some extent. For quality you can get much better out of the resin machines, but with the extruders you can print closed hollow shapes with resin. Obviously it would fill with resin. If you have something that's sort of laying down material and then bonding it with a print, you end up again with that material that's laid down actually inside the void. So the extruders allow you to print a space with nothing in it quite easily. They are fairly rough machines by comparison to other machines, but the fact you can print 2 different materials in the same print run also sets the extruders apart, and of course the hollow space. So although they are kind of rough and ugly compared to other printers, they are definitely far from obsolete, and they are still a viable option, and certainly cost-wise they give you an opportunity to print versus not being able to print because something costs $20,000 instead of $200 or $500. In any case, I'm playing with kit machines because I've got a bit of mechanical aptitude, and just to test concepts I don't need to spend big money on trying things out as to what I want to do. So I'd encourage you, if you do want to play with 3D printing, you actually have to have some technical ability anyway to handle the computer side of it, and you also have to have some technical ability to overcome any problems that you might get. So being able to build a machine is actually an asset, not a drawback. Also, being open architecture, you can change the firmware if you like, you can change the physical machinery, and with these kit machines you probably will end up making quite a few parts for yourself, so learn a heap out of this. So if you are interested in playing with 3D printing, this is a good way to get started. Some would recommend to just buy a closed machine for $1,000 to get working, but I think that buying sort of something that you turn the key and go, you kind of, well, there's advantages that it just works, but there's disadvantages that you're not actually gaining the knowledge. So even if I do end up buying a fully, I'm going to say a closed system where I can't modify it because it's been designed to operate a certain way, I may end up doing that in the future, but it's based on knowing what's behind the machine. So it's a bit like anything. There's lots of automated systems. If you've got a green button and don't understand what's behind that green button, and you go to another place and their machine's got a blue button, you might be stuck. So if you understand what's going on behind the machine, you're much more equipped to handle whatever might be thrown your way. Also, with these open machines, systems that protect you from making stupid mistakes also stop you from doing really cool things that an open machine or an open system lets you experiment with. So, not only do you learn more, but you might also come up with a trick, because you can change things that otherwise you would not have been able to come up with, because a closed system locks you out. Anyhow, that's my little bit of preaching. I'm enjoying using this machine, funny enough, even with all its weaknesses and quirks. Well, that's it from me. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.